Good evening, guys. I hope that you are doing well. Long time no see. So I have been off for quite a long time now, and the reason being, the last year when I was about to come up with the return to libc attack video, I got a job at that time, and honestly, I didn't have a job. I had no money at that time, so I had to take the job, and the job was completely non-technical. And at that point, I thought my cybersecurity career or my technical career is going along with it, but fortunately that didn't happen. This year I got a job as a cybersecurity analyst, and I do not have a lot of time now, true, but I have the power to make some videos like this, like I did that time. So anyways, today's video is about a very common technique, maybe even a bit outdated too, that is pass the hash along with PSExec. Now these two are completely different terminologies. Both pass the hash technique and PSExec has no correlation between them, but these two are used in conjunction in the lateral movement, or in this specific zone of the lateral movement within this red teaming and cybersecurity world. So the attack is pretty much easy. So if you are here just to know how the attack works, or how to move laterally to another computer within or without the Active Directory environment, so this is maybe not the right video for you, because this is more of an intermediate type of video where I explain how exactly that works. Because if you just go to YouTube, there will be 100 5-minute videos about how to perform a pass the hash attack along with PSExec. So it will be over in less than 5 minutes. So if you just want to use it, this might not be that video for you. But if you already know what PSExec and pass the hash is, this video might just fit you. So I will be demonstrating what exactly happens behind the scenes. So PSExec might be from Metasploit or Impacket. The whole thing that I will show you today goes on in there as well, but in the background, so you or the hacker who is performing the attack doesn't get to see what exactly is happening. So that is what I will be explaining today. Now, just to talk about PSExec and how and why it works. First of all, in your computer, if I just come up to your network and try this with your computer, there is a very high possibility that I won't be able to perform the attack. The most important reason for that is you do not probably have a shared folder lying in your computer, first of all, and even if you do, that might not have read and write access. It's possible. And the most important thing is, if your admin shares, that is the C and Windows directory, is not shared publicly for the network people to use, then probably this attack is not going to work very well at all, because enabling that admin shares is very important in this part. So now why PSExec is such a well-renowned tool for hacking is because in IT infrastructures where the companies are not using aftermarket or third-party softwares for IT administration, they're probably using the Windows default administration services along with Active Directory to do this type of things. So maybe you have a problem with your computer, you raise a ticket to the IT sector, the IT administrators team guys will either come into your computer and right-click and go run as administrator, and they know the password for the user administrator. So they log into your computer, do stuff, maybe fix your problem, or it can be even done remotely via RDP. So in situations like those, PSExec needs to be enabled, because, for example, there might be a group policy. So in a group policy, maybe there are softwares that are listed that needs to be installed in your computer, or even if the IT guy wants to install a computer to your workstation, they have to just log into your workstation and do stuff. They might have to keep files and folders for permanent usage in your network. So for that to happen, every computer needs to have Windows, the base Windows folders enabled via sharing to the local network by default. Now, in default Windows installations, that is turned off by default. So one has to enable it manually, and in IT infrastructures, this is possibly done with a group policy. So every computer that Windows is installed, a custom image provided by the company, when it's installed, those folders, those Windows folders, those admin shares will be turned on as network shared resources, or network shared folders to be used by other people, maybe an administrator or someone, maybe a malicious actor who has the credentials of the administrative user and his password. So that can happen. So that anyone can log in to that particular resource or have access to that particular files or folders that has been shared. So PSExec was done by Windows. The process is enabled by Windows by default, just for IT administrative purposes. If you download sys internals tools from Microsoft, there is this file called PSExec, and that will do the exact same thing as hackers do. But the Microsoft enable this option so that it becomes a little bit of easier for IT administrators to do the job. But hackers has somehow bypassed the intent of using it, so they can now directly log into your computer, use those shared folders that is only supposed to be enabled or accessed by the administrators. So they will use those folders and do malicious stuff with it. So, and pass the hash along with PSExec is just an addition of PSExec. So where you do not know the password of the administrator, but you somehow have the hash from a previous attack, or attacking maybe another branch of that company. So you probably have access to an administrator account, and you want just to test if this administrator account is enabled here as well, maybe in another branch of your company. So if the hackers get to know one of those administrators' usernames and passwords, maybe even not the password, but the hash, the NTLM hash. If you do not know what NTLM is, Google is there for you. So if they has the NTLM hash of the administrator, then we do not need the password. The hacker does not need the password in clear text. They can just simply log into that shared folder or resource via communicating with the SMB protocol, and then log into that resource with just the username and the password hash. Now the interesting thing is, the password was never even sent over the network ever. So when the hacker even knows the clear text password of the say administrator, even then the hash is only used. Now how PSExec with clear text password and PSExec with pass the hash is not much different in the point of view of the resource or in terms of the methodology. I will come to that, but really very truly just the password hash is used in pass the hash technique along with PSExec. But even in PSExec with just the clear text password, that password is ultimately converted to the hash only. So there is not much technological difference, but I will demonstrate with images and with my computer. So I will just cut me off from the screen now and directly go to the computers to show what I have today. So here I am in my computer. I will just pull up an image that will help you. So I will be demonstrating what happens in the Active Directory environment, and after that I will be explaining what happens when there is no Active Directory at all. So first off, let's say this is the shared resource. If you can see my mouse pointer, this folder, say that this is the shared resource. Let's assume that this computer has this username called admin, and some password is there of course, but you have somehow gained access to that username and password. So at this point, when you try to hack this resource or get access to this resource from a different computer with the username and password that is stored within this computer, how will you do it? So what happens is, I will take the example of this computer here. So let's say this computer wants to access the resource, so it sends a hi message. Now this is exactly not a hi message, I am generalizing a lot, but let's say that it is saying hi to the resource. What will resource do? It will give off a challenge to the first computer, to the requesting computer. So let's say that the challenge is ABCD. Now again, the challenge is not this short, but I am generalizing a lot because of the easiness of understanding. So just bear with me. So let's say the challenge is ABCD that the resource sends to the computer 1. On the next slide I am going to show you that in this computer there is the LSAS process that is running within the computer, and this LSAS actually has the username and the password for administrator stored within it, due to single sign-on procedures. So whenever you log into the computer for the first time, LSAS doesn't have anything by default. So when you log in, LSAS stores the username and password, it caches the username and password. So every time you want access to a resource and the username and password is needed, it will not prompt you for login anymore, but it will use the cached username and password as a form of single sign-on. So that is the purpose of LSAS. So let's say the password for administrator user is 1234, and that is stored in this NTLM memory space in the RAM. So what Windows does is it takes the password for the administrator and it encrypts ABCD with that password hash. Remember, 1234, let's say that this is not the actual password, because LSAS actually stores the hash of the password, not the password itself. So I am again generalizing because a hash is longer than this. So let's say 1234 is the password hash for whatever the password may be. So what happens is Windows encrypts the original challenge sent by resource with the password hash of the administrator user. Let's say the encrypted response comes out as 5678. Again, I'm generalizing, this doesn't happen in real life, but the procedure is exactly the same. So what Windows does is it sends this encrypted response 5678, that is the result for for encrypting ABCD, that is the original challenge, with the password hash of the administrator user, and sends this response to the resource so that the resource can validate this login activity and give access to the computer 1. But there is this Active Directory, so the resource, or let's say the resource is a shared folder that is lying on another laptop or another computer, so that computer will not be in use to validate the login because the Active Directory is there for that purpose. So what the resource computer does is it sends the response that was originally sent by computer 1 by encrypting the original challenge. So it sends the response to the Active Directory. It also sends the original challenge that the resource sent to computer 1, that is say ABCD, and the username that requested the access. So we already know from this slide that the username was admin. So the username, the original challenge sent by the resource, and the response sent by the computer 1 is sent to the Active Directory. Now what Active Directory does? Active Directory has all the information of all the users in a domain along with all of their password hashes. Alright, so it has every username. So if your company has 500 user accounts, the Active Directory stores all of those 500 usernames and 500 password hashes in its database. So what it does is it decrypts a response. So the response was, if you remember, that was 5678, and the original user hash, the user password hash, that was 1234. If you remember, this was 1234 was the administrator user's password hash. So it decrypts the response that was 5678 with the password hash 1234 and gets a result. So in this case, the result is ABCD, because this is a legitimately authentic authentication that has been happening. Because if this was say ABCF, then ABCF does not match with the original challenge sent by the resource. But again, ABCD is the response we got by decrypting the response with the password hash, and ABCD, if you can see in this part, if challenge is equal to decrypted value. So what was the challenge? It was ABCD. What is the decrypted value? It is still ABCD. So both of them are ABCD, which is a match. AD will say to the computer, this is okay to authenticate. Okay, so I will just say that again in a shorter way. The first step, computer asks for the access to resource. Resource sends the challenge to computer 1. Computer 1 encrypts that challenge with the password hash of the resource of the user that is asking for access. Then it encrypts the challenge. It takes the response and sends back to the resource. The resource now sends the response, the original challenge, and the username asking for the access to the Active Directory. Active Directory performs the same thing that computer 1 does but reverse, that is computer 1 encrypted, AD is decrypting. With what? AD already has the username and password for the administrator user, so it is decrypting the response with the user's password hash that AD has within itself, and then after decrypting it gets a value, say that is ABCD. Now the original challenge was sent to the AD by the resource, which is ABCD. Also the result of decryption came out as ABCD, so both of them match, which means the user is a legitimate user asking for the authentication to the resource. And that when that happens, the AD says, okay, you are good to go, the access is legitimate, there is nothing to worry about, and that's it. So that is what happens in an Active Directory environment when a computer asks for access to any other resource. That resource might be a shared folder, that resource might be another computer, that resource might be a printer. So that is what happens in an AD environment. Now the only difference, because this is important, because pass the hash and PSExec works quite well in both AD and non-AD environments. So I'm going to explain exactly on what happens on both an AD and non-AD environments. So take this AD off. What happens is, now imagine there is another laptop behind this resource which has the shared folder. So let's say from the first, again computer 1 asks the resource, hi, I want to access. The resource sends a challenge, again with the administrator user's password hash. The encryption happens for the challenge, the response is sent back to the resource. Now last step, this portion does not happen at all, but what happens is, let's say this user admin with the password hash of 1234 is residing within this computer. This computer is invisible, I am just asking you to assume that there is one. So this computer already has the password and username for the administrator user, right? So let's say this is the hacker's computer, and the hacker does know the username and password from a previous foothold attack, let's say. So what it does is, it asks for this resource with the administrator and username and the password hash for the administrator. Now when that happens, in case of a non-AD environment, the resource is not going to send the response, the challenge and the username to the AD, but as the second computer already has the information about this admin account and its password right within its own memory, the validation will not be done by the Active Directory server, but by the holder of the resource itself. So if this was computer 2, which has the information of the administrator user and its password, the same process will happen, but from this laptop, from the laptop where the resource or where the shared folder is. So the laptop has the password for the administrator, right? Because the original username administrator is residing right within, in say the second computer, right? So the second computer also has username and password. So it will take the response and decrypt it with its own computer's administrators and password hash. If the result comes out to be the original challenge that was ABCD, then this computer sends back to this hacker computer saying, okay, you are good to resource, because I have manually checked with the admin and password you sent with my version of administrators and password, and that is a match, hence you are good to go. So that is basically the first step for PSExec. I will now move on to PSH, and I will explain the other 2 to 3 steps that happens in PSExec. So now the next part for PSExec. So say this hacker wants to connect to the resource, say that is the resource being the victim, to any of those 3 folders. Maybe it's the admin shared, that is the C Windows folder, or the C folder, the C directory itself, or any other personal shares that the resource might has. So let's not discriminate there, it might be any of them, but for our sake of understanding, let's say that the admin share is being requested by the hacker, but with or without the password or the hash. Now this is where pass the hash comes in. So if you remember from the previous slides, whatever happens, that is authentication is happening either on the Active Directory server or the resource computer, wherever the environment might be, the original challenge is either way encrypted every time by the password hash and not the original clear text password. So for example, say if the clear text password was root, that root password is never used to encrypt the challenge. Whatever the scenario might be, either the Active Directory might be authenticating or the resource computer might be authenticating, whatever the environment is, every time the encryption is being done by the password hash. Also, in case of authentication, either it's an AD or not, the response code is also decrypted by using the hash of the password that is either stored in the Active Directory or the resource computer. But again and again, it's never the original clear text password that is used to either encrypt or decrypt or validate or whatever. Every time the hash is used. So what pass the hash does is it enables the hacker by using the SMB protocol directly to communicate with the resource such a way that if the hacker gives the password, then PSExec will turn that into a hash before encrypting that response. And in case we enable the PSH, so if you remember in PSExec from Impacket, when you want to use the hash of the password, you have to give that command that I want to use the hash. Even in Metasploit, when you are using PSExec, then you have to actually go to show options and enable the password, the use of password hash. So whenever one of these switches, maybe in Impacket or Metasploit, whenever you are sending the clear text password, you do not have to mention that use pass the hash technique. Then in that case, PSExec will turn that password into a hash by default. Now if you do not have that clear text password, then you enable this switch in Metasploit or Impacket to say that okay, I do not have the password, so I am directly providing the hash. You can just directly go ahead and authenticate with the resource. You do not have to make the hash of what I give, because I am directly providing you the hash. You do not have to rehash it because I am giving you the hash. If I have given a password, you had to go with hashing the password, but in this case I'm directly providing the hash, and that is why you can just go ahead and directly authenticate with it. You do not need to perform the hash of what I am providing you as the password. So at the end of the day, what we understand from here is that whatever the scenario is, only the password hash is used from the point of view of either the resource or the AD. They do not care that I am using pass the hash or not. I am using PSExec along with pass the hash, or I am using just PSExec. They do not care about it, because all they are receiving or all they are authenticating with is the hash. So when we are getting the option to use or not use pass the hash, that is dependent upon what we have. If we have the clear text password, we can simply go ahead with the password and do not provide a hash directly, so that PSExec along with pass the hash, that tool either provided by Metasploit or Impacket, that tool will convert the password into a hash. And when we do not have the password in clear text, but we do have the hash, in that case PSExec from Metasploit or Impacket will not convert that into a hash anymore, but directly go ahead and authenticate with the victim, that is the shared folder or shared resource view. So now I am coming to the next steps with what happens after this shared folder, say admin dollar or dollar admin, whatever you like to say. So when the access has been given to the hacker, now what happens? At this point, the hacker will check for read and write permissions to the admin directory. Now, as I have told in the very first part of the video, that if the read and write access in this admin folder or the shared folder is not there, then PSExec will fail miserably. So it will first check for read and write permissions. If there is a read and write permission, then what hacker will do, it will upload a service image to the victim. What is a service image? When you type services.msc in Windows, a window pops up with hundreds of services that are running, that are supposed to run in the start of the computer. So that service image, so you can also install a service image manually, and that is what exactly the hacker is doing. So it uploads a service image to the victim. Now that service image is then installed by the hacker in the victim's computer, and after the installation of that service image, it starts the service, and upon starting the service, we get there is a backdoor code written within this service image. So when I say that, please remember this. In case of PSExec, the file that is being uploaded by the hacker has the backdoor code within the service image installed. So when we are starting the service, it will just connect back to the hacker via the backdoor that is installed by default within the PSExec service image, right? So when that happens, at this point we have performed a successful lateral movement where I can install softwares onto this victim with a non-malicious intent. We can perform IT administrative jobs, and that is what exactly happens when a non-malicious actor is using PSExec to do normal IT administration jobs. This is what is exactly happening. Just the difference is, in this case, that the user who is accessing the shared resource is not someone with an intent to install softwares or do IT administrative stuff in the target computer, but instead do malicious jobs. So when we do have the CMD shell, at this point we can upload files, download files, we can perform illegal malicious activity like a hacker does, and that's the end of the story. So in short, pass the hash is nothing from the point of view of the resource or Active Directory. Pass the hash is only important to the hacker here, because that depends upon if the hacker has the clear text password or the password hash. So if there is the password hash with him, the pass the hash technique along with PSExec that is inbuilt within Impacket or Metasploit has the ability to directly communicate with the resource and encrypt the original challenge sent by the resource, or in this case victim, with the password hash. So when we are explicitly mentioning that I am providing a password hash, you do not need to rehash it, you can just go ahead and authenticate with the resource. In that case, pass the hash is working, that switch is working, that part of program within PSExec is working, and when we have a clear text password, pass the hash portion of the code is not working anymore. In case of PSExec with the normal clear text password, PSExec is normally just hashing out the original clear text password, and then it is communicating with the resource, so it can go ahead and authenticate with the resource and get the job done. So that is what pass the hash and PSExec is in short. I will now go to my Windows and Kali computers and I will show you directly how PSExec actually work. Now just to say, I will not be able to show pass the hash technique because for doing pass the hash I need to have direct access to the SMB protocol. I need to communicate in protocol language and not just there is no provision that when I do this in CMD or whatever the platform is, when I do this and when it asks for the password, there is no provision to directly just give the hash. That is only possible because PSExec from Impacket or Metasploit has the ability to enable the mode of pass the hash within themselves. So because they have the direct access to the SMB API, they can do that. CMD doesn't have access to the direct SMB API. It does not hold the code. There is no code written within CMD to directly pass the hash for authentication to the resource. So that's the difference. I will be not able to show how pass the hash works, but I will be showing how PSExec works with my computer. So here I am in my Kali machine. I will just quickly check the IPs of each of these machines. So I will be using this Windows 10 64-bit as the target machine. So let me just check what is the IP. So 104 is the IP. What is the IP of the machine that I'm using? I'm going to use to perform the PSExec. I will just check. This is 106, okay, and then this is the backdoor receiving end. So this will be the actual hacker machine. So 105 is the IP. Okay, no problem. First, what I will do is I will make the service image. All right. So, okay, I see that I have already typed that. No problem. I will just Windows Metasploit reverse TCP. Now the local host is 192.168.1.105. What? Okay, I see I have done some mistake. I will just go ahead and clear it out. Yeah. Okay. Airport is going to be 4444. This is the type of extension that I am going to use. That will be exe service. Now the service means this is not going to be a standard exe but a service image. Alright, so I will just name this as, say, I will make it interesting. So let's say I will give it DLL host. I see the DLL list is right here. I will wait for MSF to complete. Now it's completed. I will just host this file so that I can download it from my PSExec machine. So I will just go ahead and host this. Okay. I will just go to desktop. With this I am just downloading the tool, nothing else. Yep, DLL host has been downloaded. Now what I will do is I will connect to the resource of Windows 64-bit. That is, I have shared this file, so I will just go to computer management and show you. Let's go to computer management. Shared folders. If I go ahead, you will see that I have the admin shared and enabled, and I will just log into this one. I will ask for access. Now in my previous, when I was practicing before this video, I have already done this once. That's why it will not ask me for the password that is in clear text, not the hash, because CMD by itself doesn't have the capability, it doesn't have the code to perform a pass the hash, but it does have the kind of power to do the PSExec. So the password has already been given before, so it will not ask me for the password anymore, but I will just say when usually it asks for the password. So what I will do is I will just copy the DLL host to 192.168.1.104, that is the victim machine, and I will go to the admin shares, and that is where I am going to be copying the file. It is saying one file copied. So at this point, for checking purposes, what I will do is I will go to Windows directory and see if there is a DLL host. You can see that the file DLL host has been uploaded to the target computer via the computer where I am performing the PSExec with. So I will just close this. Now what I will do is create a service remotely in the victim machine via this machine where I am performing the PSExec with. So for that, what I will do is go for service, that is the service exe, standard command to create, delete, start or stop or restart a service. So I will just go for SC, then the client name, because I am doing it via remote. So I will just go in with the IP of the victim machine, that is 192.168.1.104. Create, that is the switch for creating the service. I will give it a good name such as, say, Windows update. And now it comes is the path of the file that I have copied in. So the path of the file would be bin path, let's say C Windows, because admin share is the same as C/Windows, and then DLL host was the file name, if I am not wrong. So it is showing that the service creation has been a success. So now what I will do is the backdoor, look, the backdoor code is already written in the DLL host, right? And this DLL host is selected, is now and now this DLL host is now a part of the standard services in the victim computer. So for any backdoor to work, we need a listener server. So that I will make now in my Kali machine. I will just go to MSF console. I will use Metasploit as the reverse connection handler. Let me give it some time to start it up. It's now started. So let's make the handler use multi handler. It is showing that the default configured payload is generic / shell reverse TCP, but in our case it was reverse TCP. So what I'll do is change the payload to Windows Metasploit reverse TCP. Show options. Let me see if everything is all right. Okay, the local host is missing, so I'll just go with set host 2.1.105 was it right? Let me just check. Yep, it was 5, so that here it is. I will just go ahead and go with exploit because everything is same. Now, as of now, I have created the service. Now I have to start the service. So similarly, I will just go with service exe. Again, because I'm doing this remotely, I have to go with 1.104, and this time I will go ahead with start Windows update. It is showing that the service is running, and I should get a connection back by now, and here it is. If I just go ahead and go, who am I? Okay, so I have to go drop down to shell, so I will just go with sysinfo, and it is showing that the victim machine is indeed hacked. I will check this name. This is the name that is showing I have hacked into. I will go to this computer for proof and just go with host name, and you can see this is the same computer as what is written here. So similarly, when I use Metasploit or Impacket for PSExec, for performing PSExec, at the end we get a metadata connection, right? So until this point, everything that I have shown is actually what happens behind the scenes when we use PSExec. So from creating the remote service to downloading the payload file, from copying that payload file into the administrative shares in the target computer, from starting the service, and from handling the reverse connection, everything that I have shown you right now is done autonomously and automatically with the help of PSExec from either Impacket or Metasploit, and at the end we get a metadata connection. So that's it. That's the end of the story for today, and I think I took a little bit of a long time to explain this, but I thought that something like this should be cleared at its most binary level, because it took a lot of time for me to understand this personally, because everyone uses PSExec, and how to use PSExec tutorial is more like 3 to 4 minutes of a video or a 3 to 4 minutes read, but that's not what I like about the cybersecurity world. I love the going back to where it started kind of thing. I like to reinvent the wheel, and I will say that this is not a very advantageous thing to have in this world, but again, I like to do these things. I like to know what is happening behind the scenes without my permission. So here it is. I gathered this knowledge for a long time because there is not very much articles on the internet on how it happens. There are some articles though on how it happens in a domain environment, but there is not a lot of articles how it happens in a non-domain environment, and again how PSExec works in this binary level along with pass the hash. So again, I will just turn this camera on for a second. Where is the camera? Yep. So I think I was a bit of help today. So for the next video, I don't know what video it will be, but I'm sure that I will come up with something like this where I just demystify a topic for 5 minutes in a 40 minutes video maybe. So I hope I was of some use today. I really wish that some of you who wanted to know what happens behind PSExec got to know now. So until next time, stay well, goodbye.